and I would like to speak about using USRP B210 as platform for building elements of the mobile network, namely OpenLTE. There is a short overview of the presentation. So, first point is how to design and realize the LTE node B with USRP. Second point is evaluation of the current results and usability, and there will be time I will show you some practical demonstration. The first point is what is OpenLTE? It's an open source project focused on LTE and NOB implementation. It's in a development from year 2012, but it wasn't there wasn't implemented NOB implementation yet. It was just for scanning existing OpenLTE networks. But from version 18.0, which was released somewhere at the start of the December last year, it was the first implementation of packet-oriented communication in eNode B, so we can now see some packet communication in, for example, Wireshark. OpenLTE is supported by many software-defined radios, but only with USRP B210 it can be established as eNode B. Design and realization of the LTE eNode B. So, if you want to design or do our own LTE eNode B, we need to first assess and configure the custom eNode B access point with the defined radio USRP B210. And we need also the software OpenLTE. Then we need to do some spectral analysis of available radio bands because we don't need to interfere with already existing radio bands. And also some mobile phone can have problem with interfere radio bands which are already occupied. Then we can register and configure our user equipment. If we have already all of this done, we can, for example, analyze packet communication between the user equipment and OpenLTE, and we also can test analysis of the packet communication between them. At the end of my presentation, I will try to evaluate and of achieved results and functionality. So there is some experimental workspace scheme. So the core of this network is PC with installed Linux operation system. In this case, it's operation system Linux Mint 17.1, where is installed OpenLTE software and USRP B210 itself. They are connected through USB cable 3.0. As a user equipment, I used my mobile phone Samsung Galaxy Core LTE with LTE support. There is an analysis of the used band in Czech Republic. Namely, it's band GSM 900. So we cannot use this UMTS band 8 in our configuration for OpenLTE because it can interfere with this network, and also our mobile phone couldn't find our OpenLTE network. First thing we need when we want to register our mobile phone into OpenLTE network is SIM card. We cannot use standard SIM card because those SIM cards we have from our operators don't have publicly shown a key which we need for authentication in our OpenLTE network. So we need to program our own custom USIM. We can use any of the programmer for USIM cards, and we need also blank USIM card which we use. two parameters we need to know is the IMSI number and the key for authentication into our network. There is a configuration of OpenLTE itself. So on the left side you can see configuration of the LTE parameters, such as which UMTS band we will use, what bandwidth, what frequency we will use, what DNS address. If you want to capture the packet communication, we can enable PCAP, or we can use Wireshark Live, so we can capture it on the go. Also, we can define MCC code and MNC code, and central frequency for downlink and uplink. We can also use configuration files, so we can save our configuration, and then when we start our OpenLTE network again, we can read from these files. On the right side, there are radio parameters. They are for USRP itself, and it shows us what USRP we have connected and gained from the transmission and receiver side and the antennas. We can also use variable clock sources like GPS-DO, but in this case we are using standard GPRS USRP clock signal. These are messages after we register into our OpenLTE network. We can see that user authentication is successful. This is due to we specify the key and IMSI. Also, we need email number. Next, we see there is our mobile phone or user equipment is fully attached into the network. And there are some signaling for, we see that we have default bearer set up for our mobile phone. There is some signaling messages, like you can see we have received our physical physical and PDU carriers. Also CRRD is assigned, and downlink and uplink channels are also assigned. There is some packet communication code in Wireshark. The current version of OpenLTE have some synchronization and stability issues, and also it can handle TCP packet very much. So if you can see, TCP packets are just retransmission, and there are also fragments of TCP communication. So the packets we can communicate through is only DNS packets and ICMP for pings. So evaluation of the current results is that project of OpenLTE is still in early alpha version, so it's quite unstable. And some bigger packet communication can really quickly shut it down, and we have to start it over. But it supports basic IP packet communication, and it can also be provided for functional logging of communication between user equipment and OpenLTE. As the usability of the OpenLTE in current version, it could be used for studying mostly LTE signalization and basic IP communication. But if there will be implemented some more services like voice over LTE, it can maybe be as good as OpenBTS. So now I can show you some practical demonstration. I hope it will work. At least signalization will work. I am not sure about packet communication. So first we need to execute LTFDD inode B. That's the standard command for starting up the inode B on the USRP. now we can see the firmware image is loading up. And now we can connect to control port through the telnet. So I will connect to the telnet on the port, and we can see now we can operate with the open LTE. If we type help, we can see all parameters that we can set up. There are also parameters such number of antennas used and ID of cell, but we don't need it to set up right now. I set up the band 20 with bandwidth 5, so it should work. If we want to see some log and signalization, we can also use the telnet with port. And we can now we can start it with just we need to specify the gain of the receiver and transmission antenna before we start it. It's not saved in this configuration, so we need to start it all over again when we shut it down. So it's just write, and then we write gain. For laboratory, it's conditions. It's like 85. Not interfere with other networks. For a receiver side, it's 35. Now we can start our network. What we can see there is some test signals of the upload and for upload and download side of the OpenLTE. So if there are U and L messages, it's all good. When there are O messages, that means that something went wrong and the test transmission went wrong. So there is signalization. And now I will try to connect my mobile phone to this network. As you can see, there is a lot of signalization messages, so they can be saved into log for some pose editing or reading or something. If we you can see now the info messages that our user equipment is successfully attached to the OpenLTE, and we can now see all the signalization. There is also a lot of messages. Now I can try the Wireshark, but I'm not sure that it will work in this school network because I tried it before, and there was some problem with security. But I will try it. Maybe it will work. Device used for this is Tune OpenLTE. So you can see some DNS protocol messages trying to query from this OpenLTE network. If I try ping, okay, I see MB, it doesn't work. Secondly, I will try to ping the tunneling device of the OpenLTE. It doesn't come through. I think the problem is maybe in addressing of the network or some security. But as you can see in the presentation, there is some messages that can be captured. Mostly it's ICMP and DNS. maybe the UDP can go through also, but the TCP is problem at the moment. And maybe in the other next implementation can be handled. So that's everything for the presentation.
Okay, thank you very much.